Greetings and welcome to the Introduction to Astronomy. In this week's Astronomy of Other Cultures, we are continuing our look at Muslim astronomy, and we'll talk about the astronomer Ibn al-Haytham and look at his contributions to astronomy. So, Ibn al-Haytham, we can see here that he lived from about 965 to 1040 and worked on a number of different things, including physics, astronomy, and mathematics. And one of the things he is best known for is really being the father of modern optics. And his big work was what was titled, as you might guess, the Book of Optics, or the Kitab al-Manazir, which was 7 volumes on optics. And he studied things like the law of reflection, and even looked at how vision works and gave us some of our earliest modern understanding of how vision works. And we can see one of those sketches here with the eyes there as to how the different pieces worked and put together. So this was one of our earliest understandings of optics and how vision works within the eye. Now, in terms of astronomy, he is best known for his Doubts Concerning Ptolemy, published around the year 1025, and he looked for contradictions in Ptolemy's work. And there was something that bothered a lot of people about Ptolemy's work, and one of the primary things was what was known as the equant. Now, the equant, seen here, is that point opposite the Earth. So you have the center there marked by the X. You have the Earth down there below it. So the Earth is not at the center of the orbits of the planets. And then you have the equant on the other side. Now this is needed to adjust things and to make the planets, explain why the planets can change their speed, why they change their apparent speed, and why they can change their apparent size correctly. So this was needed to explain it, but the idea of the equant was troubling. It just didn't make sense to a lot of astronomers of the time. And you really wanted, if you were going to have a geocentric universe, to really have the Earth at the center and not have to use this device to try to match the observations that are seen. So what he came up with was a model of the motions of each of the 7 planets, which was his work on the geocentric universe, eliminating the equant. So he was able to eliminate the equant, but yet keep the observations and predictions as accurate as Ptolemy's, if not better. And the whole idea is that, you remember, that things are getting better. As we go through time, we're making more accurate observations. So the problems in the geocentric model are becoming more and more apparent because we're learning that it is not correct. But we haven't quite been able to make that jump yet to going to a sun-centered model. That will not happen for hundreds of years beyond this. But people were continuing to work and make modifications to really help better understand and predict how the planets moved in our solar system. And of course, he also wrote dozens of other astronomical works, some of which still survive, and we still have references to those. So let's go ahead and finish up here with our summary. And what we've looked at today was, we talked about Ibn al-Haytham, who lived from about 965 to 1040, considered the father of modern optics. And then he reworked Ptolemy's model to remove the equant, which had caused problems for a lot of astronomers. So that concludes this discussion on astronomer Ibn al-Haytham. We'll be back again next week to talk about another astronomer of the Muslim world. So until then, have a great day, everyone, and I will see you in class.